In 2015, astronomers discovered something that broke all the rules. A star 1,480 light-years from Earth was doing something so bizarre, so unprecedented, that serious scientists uttered two words rarely spoken in professional astronomy: alien megastructure. This wasn't tabloid speculation or conspiracy theory. This was Yale University. This was Penn State. This was NASA. For the first time in modern astronomy, the possibility of discovering an alien civilization wasn't just whispered in corridors. It was published in scientific journals, discussed at conferences, and investigated with the most powerful telescopes on Earth. Today, we're diving into the mystery of KIC 8462852, better known as Tabby's star. The celestial object that forced humanity to confront a stunning possibility. We might have found evidence of a Type 2 civilization on the Kardashev scale, being so advanced they can harness the entire energy output of their star. Join me as we unravel one of the most captivating detective stories in the history of astronomy. Our story begins not with professional astronomers, but with citizen scientists, ordinary people sitting at their computers, sifting through data from NASA's Kepler Space Telescope. Kepler's mission was simple but ambitious. Stare at 150,000 stars continuously, watching for the telltale dimming that occurs when planets pass in front of them. The Planet Hunters project invited anyone with an internet connection to help analyze this data. The human brain, it turns out, is remarkably good at spotting patterns that algorithms might miss. And in 2011, several citizen scientists flagged something extraordinary. A star that was dimming in a way nobody had ever seen before. When a planet transits its star, the dimming follows a predictable pattern, a smooth, symmetric dip in brightness, typically less than 1%, repeating at regular intervals. But KIC 8462852 was different. Catastrophically different. The star's brightness would plummet by up to 22%. That's blocking nearly a quarter of a star's light. For perspective, Jupiter, the largest planet in our solar system, would only block about 1% of the sun's light. Even stranger, these dips were completely irregular. Sometimes the star dimmed for days, sometimes for weeks. The patterns were chaotic, asymmetric, like nothing in astronomy textbooks. One citizen scientist, Daryl LaCourse, wrote a simple comment that would launch 1,000 investigations. "This is bizarre." Tabitha Boyajian, a postdoctoral researcher at Yale, led the professional investigation. Her 2015 paper had the unusual title, "Where's the Flux?", a playful acronym that captured astronomers' bewilderment. The star became known as Tabby's star in her honor, though Boyajian herself would be the first to credit the citizen scientists who found it. To understand why Tabby's star caused such excitement, we need to grasp just how weird its behavior truly was. Imagine you're watching a streetlight from your window. Occasionally a bird flies past, causing a brief, small shadow. That's a normal planetary transit. Now imagine that sometimes something blocks almost a quarter of the streetlight, but you can't see what it is. And whatever it is, it's not round, not regular, and appears to be changing shape. The Kepler data showed at least two major dimming events. In March 2011, the star dimmed by 15%. Then, in February 2013, it dimmed by an incredible 22%. But these weren't simple dips. The light curve, the graph of brightness over time, looked like a city skyline, with complex structures, multiple peaks and valleys, suggesting that whatever was blocking the light had an intricate, irregular shape. Between these major events were hundreds of smaller dips, seemingly random, with depths varying from 0.5% to 2%. The entire pattern was non-periodic. Planets orbit like clockwork. But whatever was affecting Tabby's star seemed to follow no schedule, no pattern that could be modeled by conventional celestial mechanics. But here's what really got scientists talking. The star was old and stable. This wasn't a young star, surrounded by a protoplanetary disk of dust and debris. This was a mature F-type star, slightly larger and hotter than our Sun, well past the age where it should have any significant amount of material orbiting it. It was like finding a teenager's messy room in a senior citizen's home. It simply shouldn't exist. The infrared observations made things even more puzzling. When dust absorbs starlight, it heats up and re-emits that energy as infrared radiation. But Tabby's star showed no excess infrared. Whatever was blocking the light wasn't behaving like dust, asteroids, or any known natural phenomenon. It was Jason Wright, an astronomer at Penn State University, who first publicly suggested what many were thinking privately. In a blog post that would go viral, Wright proposed that the dimming could be caused by megastructures, massive artificial constructions built by an advanced alien civilization. The idea wasn't as far-fetched as it might sound. In 1960, physicist Freeman Dyson had proposed that advanced civilizations would eventually need more energy than their planet could provide. The logical solution: build massive structures around their star to capture its energy. These Dyson spheres, or Dyson swarms, would be the ultimate engineering project. Solar panels on a stellar scale. A complete Dyson sphere, a solid shell around a star, is probably impossible due to gravitational stresses. But a Dyson swarm, millions or billions of smaller structures orbiting the star, is theoretically feasible. From a distance, a Dyson swarm under construction might look exactly like what we were seeing. Irregular, deep diming, as massive structures pass between us and the star. Wright was careful with his words, calling it the last hypothesis standing after natural explanations were exhausted. But the media explosion was immediate. Alien megastructure may explain mysterious star, screamed headlines around the world. Tabby's star became the most famous star in astronomy overnight. The search for extraterrestrial intelligence, SETI Institute, immediately swung into action. If an alien civilization was building megastructures, they might be communicating. The Allen Telescope Array, designed specifically to search for alien signals, pointed its dishes at Tabby's star. The Green Bank Telescope, the world's largest fully steerable radio telescope, joined the hunt. For weeks, humanity's most sensitive ears listened to Tabby's star, searching for any hint of artificial radio signals. The Breakthrough Listen project, funded by billionaire Yuri Milner, dedicated significant resources to observing the star across multiple wavelengths. They looked for laser pulses, radio beacons, any form of electromagnetic communication that might indicate intelligent life. The world held its breath. While the alien hypothesis captured imaginations, astronomers worked overtime to find natural explanations. Science, after all, demands we exhaust conventional possibilities before embracing the extraordinary. The leading natural hypothesis involved a massive swarm of comets. Perhaps a nearby star had passed through the system, disrupting an outer comet cloud like our Oort cloud, sending thousands of comets plunging toward Tabby's star. As these comets approached the star, they would sublimate, turn from ice to gas, creating massive clouds that could block significant amounts of light. This explained some observations. Comets could create irregular shapes. Their tails could produce the complex light curves. The lack of infrared excess made sense if the blocking material was mostly gas and small particles that didn't retain heat. A study found a red dwarf star that had passed within 1,000 astronomical units of Tabby's star, potentially triggering such a comet cascade. But problems remained. The sheer number of comets required was staggering. We're talking about hundreds of massive comets, each one dwarfing anything in our solar system. And the timing was suspect. What were the odds we'd catch such a rare event in the act? Other hypotheses proliferated. Perhaps we were seeing the aftermath of a planetary collision, with the debris cloud still settling. Maybe a planet had been torn apart by tidal forces, creating a ring of fragments. Some suggested a massive ring system, like Saturn's, but 1,000 times larger. Others proposed interstellar dust clouds passing between us and the star. Each explanation had merits, but none fit perfectly. The comet swarm couldn't easily explain the long-term dimming. The collision hypothesis struggled with the lack of infrared. The dust cloud theory couldn't account for the dramatic variations. Tabby's star seemed determined to defy every attempt at explanation. Just when astronomers thought they were making progress, Tabby's star threw another curveball. In 2016, astronomer Bradley Schaefer made a startling discovery. He examined photographic plates from Harvard's archives, images of the star dating back to 1890. His conclusion was shocking. Tabby's star had been dimming for over a century. The data showed that between 1890 and 1989, the star had faded by about 14%. This wasn't the dramatic short-term dimming Kepler had observed. This was a slow, steady decline over 100 years. If confirmed, it eliminated most natural explanations. Comet swarms don't last centuries. Planetary collisions are one-time events. Dust clouds pass by and move on. The discovery was controversial. Historical photographic plates are notoriously difficult to calibrate. Different emulsions, different exposures, different storage conditions all affect brightness measurements. Other astronomers analyzed the same data and found no long-term dimming. The debate raged in scientific journals, with papers and counterpapers flying back and forth. Then, in May 2017, Tabby's star did something remarkable. It started dimming again, this time while the entire astronomical community was watching. For the first time, astronomers could observe the dimming in real time with modern instruments. Telescopes around the world turned toward the star. This event, dubbed ELSI, a play on LC for light curve, dimmed the star by about 3%. The real-time observations were revealing. Different wavelengths of light were blocked by different amounts. Blue light was dimmed more than red light. This was crucial evidence. Solid objects block all wavelengths equally. But dust preferentially scatters blue light. It was looking more like dust was the culprit. But what kind of dust and where did it come from? More dimming events followed. Celeste, Skara Angkor, and Karal Soup, each named after ancient sites reflecting the mystery's archaeological feel. Each event provided more data, more clues, but also more puzzles. The dust seemed too fine, too perfectly sized. It was like nature was producing industrial-grade, light-blocking material. After years of observations, debates, and analysis, a consensus began to emerge, though it's far from unanimous. The leading theory now involves dust, but not just any dust. This is circumstellar dust, orbiting the star in massive rings or clouds, possibly replenished by ongoing processes. One compelling hypothesis, proposed by a team at Columbia University, involves exomoons, moons of planets orbiting Tabby's star, being stripped away and ground into dust. In this scenario, planets in the system have migrated inward, causing their moons to be torn apart by tidal forces. The resulting debris forms massive dust rings that periodically block the star's light. This explains several puzzling features. The dust would be continuously replenished, accounting for the long-term dimming. The varying particle sizes would create the wavelength-dependent dimming. The irregular patterns could result from the complex dynamics of multiple rings and debris clouds interacting gravitationally. But even this theory has issues. The amount of material required is enormous, equivalent to grinding up dozens of moons. The lack of infrared excess remains problematic, requiring the dust to have unusual properties or temperatures. And the theory doesn't fully explain the century-long dimming, if that observation is real. Another variant involves the star itself eating its planets. As planets spiral inward, they're torn apart, creating temporary dust clouds. The star might be going through an unusual phase of planetary consumption, making Tabby's star a cosmic crime scene where we're watching worlds die in real time. Some astronomers propose we're seeing a combination of phenomena, perhaps a dust-producing collision coinciding with a comet swarm, all while the star undergoes natural variations. Reality, they argue, is often messier than our neat theories suggest. While the alien megastructure hypothesis captured hearts and headlines, the evidence has steadily mounted against it. The extensive SETI observations found nothing. No radio signals, no laser pulses, no signs of technology. The wavelength-dependent dimming strongly suggests dust rather than solid structures. Moreover, if aliens were building a Dyson swarm, we'd expect to see specific signatures. The structures would absorb visible light and re-emit it as infrared radiation, lots of it. Tabby's star shows no such infrared excess. The megastructures would need to be impossibly large and oddly designed to create the observed dimming patterns without producing waste heat. There's also the timing problem. If we're seeing a Dyson swarm under construction, we've caught it at an incredibly special moment. after it's big enough to block 22% of the star's light, but before it's producing detectable waste heat. Given the age of the universe and the rarity of such a moment, it's statistically improbable we'd catch it just then. But perhaps, most tellingly, the dimming events don't show the regularity you'd expect from artificial structures. Even a complex megastructure project would likely show some patterns, some evidence of design or purpose. Instead, we see chaos, randomness, the signature of natural processes rather than alien engineering. Yet scientists haven't completely abandoned the idea. SETI continues to monitor Tabby's star, and some researchers argue we might be looking for the wrong signatures. Perhaps advanced civilizations use technologies we can't imagine, creating effects we don't recognize as artificial. The absence of evidence, they note, isn't evidence of absence. Tabby's star has fundamentally changed how we study the cosmos. It's shown us that the universe still holds profound mysteries, that even well-studied stars can surprise us. It's also demonstrated the power of citizen science, ordinary people making extraordinary discoveries. Since Tabby's star, astronomers have found other stars with unusual dimming patterns. VVV Witzo 7 dimmed by 80%. J1407 showed eclipse-like events lasting weeks. Epic 3242709 displayed irregular dimming. Reminiscent of Tabby's star, we're discovering that the universe is full of weird stars doing inexplicable things. These discoveries are reshaping our understanding of stellar systems. We're learning about previously unknown processes, planetary collisions on massive scales, exotic dust production mechanisms, stellar variations we never imagined. Each mystery star is a natural laboratory, teaching us about extreme physics and cosmic evolution. The James Webb Space Telescope, with its unprecedented infrared sensitivity, has added new capabilities to study these objects. Future telescopes like the Extremely Large Telescope will provide even more detailed observations. We're entering an era where we can study individual stars in other solar systems with incredible precision, potentially watching planets form, collide, and die. Tabby's star has also reinvigorated SETI. The serious consideration of the alien hypothesis by mainstream astronomers has legitimized the search for extraterrestrial intelligence. New projects are scanning the sky with greater sensitivity, looking not just for radio signals but for megastructures, artificial atmospheric modifications, and other technosignatures. As I record this script, Tabby's star continues to confound astronomers. Despite years of observations and dozens of scientific papers, we still don't have a complete explanation. The star that made us wonder, what if aliens, has become something perhaps more valuable, a reminder of how much we don't know. The journey to understand Tabby's star reflects the best of human curiosity. From citizen scientists spotting an anomaly to professional astronomers developing theories, from SETI researchers daring to consider aliens to physicists proposing exotic new phenomena. This is science at its most exciting. We're watching the scientific method in real time. Hypotheses rising and falling, evidence accumulating, understanding slowly emerging from mystery. Perhaps the most profound lesson from Tabby's star isn't about aliens or dust or dimming. It's about perspective. Here we are, on a small planet orbiting an ordinary star, detecting and analyzing the light from a star 1,480 light-years away, trying to understand processes we can barely imagine. Every photon from Tabby's star that reaches our telescopes left during the Middle Ages, carrying information across centuries to puzzles in our computers. Whether Tabby's star is surrounded by disintegrating planets, unusual dust clouds, or, against all odds, alien megastructures, it has already achieved something remarkable. It's united humanity in wonder, and shown us that the universe still holds secrets worth discovering. It's reminded us that sometimes, just sometimes, it's okay for scientists to dream big and ask, what if? The next time you look up at the stars, remember that each point of light could be another Tabby's star, another mystery waiting to be discovered, another puzzle that could revolutionize our understanding of the cosmos. And perhaps, somewhere among those stars, other beings are looking back, wondering about the strange star they call our sun. What do you think is causing Tabby's star's bizarre behavior? Are we witnessing a natural phenomenon we don't yet understand? Or could there be something more exotic at play? Share your theories in the comments below, and don't forget to subscribe for more cosmic mysteries. Until next time, keep looking up. The universe is far stranger than we ever imagined.